Hello everyone, let us talk about chain rule for finding partial derivatives. So let us recall whatever you have done in 12th class to compute derivative of a function of one variable. Okay, whenever we are talking about one dimension, then we will talk about derivative only, not partial derivative. Okay, so y equal to fx, it is a function of one variable and x is again a function of t. And we want to compute dy over dt. So y is connected with x and x is connected with t. Then we can say y is automatically connected with t. So dy dt equal to what? Dy, first we will differentiate y with respect to x. Okay, and then we will differentiate x with respect to t. Let us take an example like y equal to x square and x equal to sin t. And we want to compute dy dt. So it is equivalent to what? Dy dx and then dx by dt. So what is the value of dy dx? It is 2x and dx by dt is what? Cos t. So what would be the value of dy dt? We can convert it into one variable. So x equal to what? Sin t. So 2 sin t cos t. So this is the differentiation of y with respect to t. So whenever we are talking about one dimension, so this is the procedure. You have done this thing in your first year. Now let's talk about when it is a function of two variables. So whenever function is of two variables, that means z equal to f of x comma y, or let us take three variables. Okay, and x, y, z are connected with another function. Let us suppose it is t. Okay, so x equal to maybe gt, y equal to h of t, and z equal to k of t. Okay, so and we want to compute dz over dt. Let me make a correction here. This is z. Let us take it w. Okay, now we want to compute dw by dt. Okay, x, y, z are independent variable and w is a dependent variable. We want to compute dw by dt. So obviously w is connected with x, okay, y and z. So whenever we want to differentiate w with respect to x, then it will be a partial derivative. Del w over del x, and then x is connected with this t. Then it will be dx by dt. And again we have to differentiate w with respect to y because we have to compute dw by dt. So this w is connected with three variables x, y and z. X, y and z. And all these x, y, z are connected with a single variable, that is t. So x is a function of one variable, that is dx by dt. Again, since we want to compute derivative with respect to t, so we start from w and we have to reach up to t. So we have three paths to move x, y and z. Then only we can compute derivative of w with respect to t. So what is the procedure? So first of all we differentiate del w over w with respect to x, del w over del x, and then differentiation of x with respect to t, that is dx by dt. And then del w over del y, and then dy by dt. Then del w over del z, dz by dt. So the formula that, or the partial derivative of w with respect to t can be computed as del w over del x dx by dt. So here we can see like it is partial and this is total. So what is the reason? Because x is a function of single variable. If x is a function of two variable, then we have to take del operator. But it's since we are computing dw by dt, so w, in order to compute dw by dt, we have to go through x, y, z. That's why in order to compute dw by dt, we are getting this chain rule. Okay, so how to keep remember? We can keep remember this formula by using this tree diagram. First of all, we see w is connected with how many variables? So here it is connected with three variables x, y and z. And then if we want to differentiate w, then there is a confusion, like we have to differentiate w with respect to x, y or z. So obviously this is wx, wy and wz. And then since we have not to compute the partial derivative of w, we have to compute derivative of w with respect to t. That's why we will go through t by these three paths, x, y and z. So wx, wy, wz, and then x, x, y, z are the function of single variable. So that's why we are getting dx by dt, dy by dt and dz by dt. Okay, so we can take like wx and then dx by dt. This is the first value. Plus del w over del y and dy by dt. This is the second value. And then del w over del z and dz by dt. So in order to apply chain rule in the function of more than one variable, then this is the procedure. Okay, let us take an example like w equal to xy plus x square plus yz. Okay, and x equal to t, y equal to t square and z equal to t cube. Okay, so w is a function of x, y, z and x, y, z are the function of single variable, that is t. So let us compute dw by dt. So put it into the formula, like use this formula, dw by dt equal to del w over del x. So first we are required to compute del w over del x. So what is del w over del x? That is y plus 2x. Okay, del w over del y, that is x plus z. Okay, del w over del z, that is y. If it is not clear, let me explain it again. Since we are differentiating w with respect to x, so wx will be what? We have to differentiate this function with respect to x. So what is the differentiation of xy with respect to x? That is y. Because the differentiation of x is 1, y will remain as it is. Now the differentiation of x square with respect to x, that is 2x. Let us compute wy, that means differentiate this function with respect to y. So what we will do? Differentiation of xy with respect to y, that is x is constant, y is 1. Okay, so it will be x. Differentiation of x square with respect to y, that is 0. Differentiation of yz with respect to y, that is z. Okay, similarly we can compute the value of del wz. So differentiate xy with respect to z, it is 0. Differentiation of x square with respect to z, 0. Differentiation of yz with respect to z. So y is constant, z will be 1. Okay, so that's why we are getting the value of wx, wy and wz by this way. And then we will compute dx by dt, because we have to use this formula. So now dx by dt is what? Differentiation of x with respect to t, it is 1. dy by dt is 2t and dz by dt equal to 3t square. Okay, now put the value into the formula. Which formula? This is the formula. Okay, so dw by dt equal to del w over del x, that is y plus 2x, dx by dt is 1, plus del w over del y is what? X plus z, del y by dt, del t, it is 2t, plus del w over del z, it is y 3t square. Okay, so what is coming out to be? Y plus 2x plus x plus z 2t and then y t square. Put the value of x, y, z in term of t. So what we are getting? We are getting here t square plus 2t. Put the value of y and x from here. Plus x plus z, that means t plus tt cube 2t. Plus 3, y is what? T square into t square. So this is the result we are getting whenever we are differentiating w with respect to t. Okay, let us talk about another case whenever w is a function of x, y, z and x and y are the function of again two variable, let us suppose r and s, and y is a function of h of rs. ठीक है ना? And z is a function of krs. Okay, so w is a function of three variable and again these three variables are connected with two more variables. So we can understand it with this diagram. W is a function of x, y and z. X is again a function of rs, y is again a function of rs and z is again a function of rs. So whenever we want to compute differentiation of x, w with respect to x, with respect to r. Okay, we want to differentiate w with respect to r. So what is the procedure? How to move? Okay, so we will write w is a function of first x, y, z and x, y, z are connected with R. And also W is a function of x, y, z, and this x, y, z are connected with S. So whenever we want to compute del W over del R or del W over del S, then we have to use these two flow diagrams. Okay. So first of all, let us compute del W over del X, del R. Okay. Why del W? In the previous case, we have written dW. Okay. Because all these three variables are connected with a single variable t. If you see x, y, z, they are the function of t only. But in this case, x, y, z are the function of again two variables. So whenever we differentiate x, then it will be partial differentiation. So del W over del R will be what? It will be del W over del X. So first of all, whenever we want to differentiate W with respect to R, since W is a function of R and S two variables, that's why if you want to compute derivative with respect to R, then it is partial. So it is Wx, this is Wy, Wz. Okay, this is del X over del R. Okay, del Y over del R and del Z over del R. This is partial because x, y, z are connected with two variables. So this is del X over del R. Okay, so this is 1 root Wx xr plus now Wy del Y over del R. Wy or del W over del Y upon del R plus del W over del Z over del R. ठीक है ना? So this is the chain rule to compute differentiation of W with respect to R. Okay. This one. Now similarly we can compute derivative of W with respect to S. So this is Wx, Wy, Wz. This is del X over del R. XR we can write del Y over del R. Sorry, I should write S because okay, del X over del S, del Y over del S and del Z over del S. So del W over del S will be what? Del W over del X over del S. Del W over del Y over del S. Del W over del Z over del S. So this is the flow diagram for computing del W over del R and del W over del S. Okay, you can, if you want, you can compute it by yours without using tree diagram, but tree diagram is always help us, like how to compute chain rule or how to apply chain rule when the function is of more than one variable. So let us do one example here. Like W is a function of x, y, z, x square plus y, z plus z cube. Okay, and x equal to what? That is r square s, y is equal to rs and z equal to r ln s. Okay, now compute del W over del R. So del W over del R is what? Del W over del X over del R. Del W over del Y over del R. Del W over del Z over del S. Okay, let us compute first del W over del X. So what is del W over del X? Differentiate this with respect to X. It is 2x only because y, z they are constant when we are differentiating W with respect to X. Del W over del Y, that is what? Differentiation of x square is 0 and differentiation of yz with respect to y is 1 and z will be a constant. Similarly, del W over del Z will be what? Differentiation of x square is 0, differentiation of yz. So differentiation of z is 1 with respect to z, it is 1 into y plus differentiation of z cube, this is 3z square. Similarly, del X over del R, differentiation of x with respect to R, it is 2rs. Del Y over del R, it is s only, differentiation of R is 1. And del Z over del R, it is ln s. Put the value of various partial derivatives into this formula. So del W over del R equal to del W over del X is 2x into this value 2rs plus z del W over del Y z into s plus del w over del z is what? Y plus 3z square into del z over del r ln s. Put the value of x, y, z into this expression, so 2x equal to what? R square s into 2rs plus z value is what? R ln s into s. Rs value of y is rs plus 3z square, r square ln s whole square into ln s. Simplify it, you will get the value of del w over del r. Similarly, we can compute the value of del w over del s. That you have to compute by yourself. Okay, compute it. Okay.